Okay, so this is a review for the graphing test. And there are lots of graphing type questions, and I'm going to do those with you on paper because we have this nice paper worksheet handout for you. But there's some of this that isn't graphing, and therefore I think we should do before you have this paper. Because some of you, once you get this paper, you're going to be all obsessed with finishing it and won't be able to pay attention. So first thing, let's talk about order. You know how order matters? Very good. I'm going to throw in an extra. There is a negative right there. I'd like you to tell me, these four things, what order should they be done in? 1, 2, 3, 4. I'll pause for a second while you try that. Okay, here's what you should have said. 1 and 2 can be reversed, but generally speaking, actually no, I'm sorry, I'm wrong. I'm thinking of how we do it in higher algebra. In Precalc, we are pretty strict about these, and you have to do them in a certain order. Okay, we start on the inside. Now, technically, you could start on the outside. I told you that before, and it's important to tell you that. In fact, I used to hide it from people because I didn't want to confuse them. I always start on the inside. I want you to do that, but I have to tell you, you could start on the outside because when we get to the final is written by other people, and sometimes they start on the outside, and sometimes they start on the inside for the multiple choice answers. Okay, so anyway, not all the finals multiple choice, but some are. So anyway, I need to tell you that both are possible, but I wanted you to start in here. How many of you did start in there? Okay, good. That's almost everybody. So if you start on the inside, then you're faced with a choice, and it seems like it's a choice between add and multiply by that negative, and it's not. It's a choice between doing the parentheses or not doing the parentheses. So then you ask yourself, parentheses, shouldn't they normally be first? But when you're on the inside, you do things in opposite of normal. Therefore, that is supposed to be first. And that is the inside is high-vo, right? So it's horizontal on the inside. So this is a horizontal reflection. And if you had said instead of reflection over the y-axis, I would have been okay with that. The word flip is not a math word. It's a good thing to help you understand it, but it's not correct in this part. So don't use flip. Reflection over the y or a horizontal reflection. The next thing is the other thing in there, which is left 4. Once you've finished on the inside, then you may move to the outside. Once we're on the outside, I have two choices, this or that. And this one is a multiply by -1, and that is a subtract, and there's a big difference because that multiply is supposed to be first. So this right here is going to be a, it's on the outside, vertical reflection, high-vo, vertical on the outside, vertical reflect. And then number 4 is a down 7. That is the order I was hoping you would say. Now, technically, you could have started on the outside, but if you had done that, these two would have moved up in a block up there and would have become 1 and 2. Any questions about the order? Okay, next kind. You know how we did inverses are a reflection over this line? See if you can make a reflection for that function. It's supposed to be like part of a parabola. See if you can reflect that over that line correctly. I'll pause for a second while you try that. Okay, so here's what I've been hoping for. This part is pretty easy to reflect. And then it gets further and further that way. And you'd have things like, oh, if this was 2, 8, then this would have been 8, 2. That's the thing to keep in mind for things that are inverses of each other, that their x and y's trade places. Okay, next graphing topic. Let's say that you had I had to graph that. Okay, if you're actually graphing, remember what I've told you is your best friend. It helps so much. It really, really does. What is it? XY chart. If you can make an XY chart, you can lock in so many points. Now, do I want you to know that this is left 3 and 1/3 as tall? Yes, and I'll test that in other ways, like when we have those questions that say, what order should I do it in? Then I'll know whether or not you know that part. But for here, I would just make an XY chart. And I'd say to myself, okay, instead of graphing the parabola and then shifting it to the left and then making it shorter when 1/3 is tall, I just go like this. Stick in 0, see what happens. 0 plus 3 is 3. 3 squared is 9. 1/3 of 9 is what? 3. So 0, 3 better be on your graph. I think it's quicker to do it this way than any other way. Now, some of these aren't going to work quite as nice because, you know, like you're going to have to take 1/3 of 16 or whatever, but that's okay. Just leave me a fraction answer. Get me at least 3 points on this thing. That's one of them. Choose strategically what x's you want to put in. Just make it work nice. You put in some numbers, it's hard. Some other numbers, it's easy. So what do we want to put in here? How many of you thought of putting in -3? That was smart. Know why? Because then if I put in -3, the whole thing's going to turn into 0 really fast and easy. So -3 goes to 0, but it's another easy thing to put in. 6. Okay. If I put in x is 6, 6 plus 3 makes 9. 9 squared is 81. And 1/3 of 81 isn't going to be super easy for me, but I know it's divisible by 3. What is 1/3 of 81? Oh, I did it wrong. Okay. Maybe you meant to put in x is 3? I mean, like wait a minute. This is 3 so that this becomes 6? I don't know. It's another option. But this was 81 divided by 3. Now, if I put in 3, 3 plus 3 is 6. 6 squared is 36. And then I take 1/3 of 36. So 3 would go with 1/3 of 36. So 36 over 3. Yeah, that is 12. Good. So 3,12. All right. Some other options. Maybe I should put in -2. I like it because that makes it a nice small number. -2 plus 3 makes 1. 1 squared is 1. 1/3 times the 1 is 1/3. So when I put in a -2, I got out a 1/3. All right. Now, do you get that this wouldn't have been super easy to do either way? Because when you have to stretch and get weird points like this, that'd have been hard to do on the graph too. That would have been off your graph. So could I have done it the other way? Absolutely, and I want you to understand that option. I graph the parent like this, and then I just move them and stretch them. So this is 3 to the left. Then 1/3 as tall. So that means I need to shrink it down shorter than it was. So that's a vertical squish, which also, by the way, looks like a horizontal stretch. I know that. But when you make something 1/3 as tall, it was like used to be this tall, and now it's that tall. It has the same effect. By squishing it, it sort of makes it look like you stretched it horizontally. Okay, now for that, we'll do more practice of that on paper. Next, let's talk about those squiggly graphs. It's called Solitude Functions. And actually, I should pull up a nice one here. So go into here, in there, and pull that out. And then say, let's say I have a parent function that looks like that. Now tell me, what would it, if this is f of x, what would this look like? Remember to do it in the right order. pause for a second. Okay, let's see how you did on this one. Here's the approach I would take if I were you. First of all, stop looking at your worksheet and look up here for a minute, please. I'm going to single out those green points because those are the really important ones, and then I'm going to do stuff to them. I would do this by points. Excuse me. So 2f of x. I'm going to make everything double height. So notice that first point doesn't need to move at all. This one needs to be double its height. This one needs to be double its height. This one doesn't move at all because they have a height of 0, both of those actually. And this one needs to double its height, which actually means move down. Okay, now I got to do the plus 1. I would do that to all the points, right? So move them all up 1, up 1, up 1, up 1. These both go up 1 and up 1. And check and see if your answer looks like that, the green one. Questions on that? Do it by points. Okay, now let's take that same parent function we had and move or do this to it. Let me take that off of there. Okay, you know there's two things you can do. You can do f of, undo that move. This function here, f of x. I can either put an absolute value around the whole thing. Try that. And then we'll try the other way in a second. When you absolute value the whole thing, think of what that does to this function. Remember, you're either absolute valuing the x's or you're absolute valuing the y's. Okay, if you're absolute valuing this one, you are absolute valuing the y's, which means all the positive y's, the things that have a y that is positive would all stay the same. Things that have negative, like this, that's a -1, changes to +1. So there's your answer. Any questions on that one? Okay, that was the easier kind. Though all the stuff that was down below got flipped up. What if I do instead absolute value of just the x's? I want you to turn your iPad my way once you've got this one sketched. I want to remind you, I'm fine with you doing this on regular paper, but do you remember that we made a graph that you could pull in for times like this if you wanted to? Where is it? Remind me. Did we ever in this class? I thought we did. I think it's in your photos. Okay? All right, just so that you remember how to do that. Don't have to do that on this right now, but would you please right now remind yourself how you can insert that graph? Be good for you to remember how to do that. It's insert picture. And then you go to your pictures and you find the picture of the graph. And then you pop it in there. All right, now I'm going to start checking them. I'm going to count them so that I know when I'm done. Just a second. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. 27 of you. There's 1 right, 2 right, 3 right. If I say right, that means you're right. 4 right. Unfortunately not. 5 right, 6 right, 7 right, 8 right, 9 right. Not right. Something's wrong with yours on the left side of it. 10 right, 11 right. Nope, something's wrong. 12 right. 13 right, 14 right. 15 right. Okay, we were going for 27. 16 right. So 16 out of 27 of you know it. 17 out of 27. Nope, thanks for trying. 18 out of 27. That means I have 8 people I'm worried about. So let me show you 8 people and everybody else. Here's how you should have thought this through. The x's that are negative are over here. That's where x is negative. And most of you knew to get rid of that. So yeah, you get rid of that. Now what do you do to finish it? You just have to reflect whatever's on the right side over to the left side. There we go. The new function is this green one. It's the same on the right, and on the left it's a reflection. Any questions on that? Why? Good question. I like that question. It's my favorite question, in fact. Because if I do, without the absolute values, if I just do f of x and I stick in 2, this doesn't get confused at all. It knows that the answer is 0. It said when I put in f of 2 that I get 0. And when I put in f of 3, I got negative 1. It knows what to do on the right side because nothing has changed. When I absolute value this, the positive numbers don't change at all. But do you get when I put in a negative 1 into this function that it acts just like I put in a positive 1? Because I absolute valued that number before I did it, before I put it into my function. So if I take negative 2, for instance, and I absolute value it, it's the exact same thing as if I said f of 2. And I already know what that's going to do. It's right here. F of 2, it knows the answer is 0. It's getting fooled into thinking that negative 2 is exactly like 2 because I took the absolute value of this number here, and that becomes positive 2. So then it's being asked, what's f of 2? And it already knows the answer from the right side. F of 2 is 0. So it knows it has to say this. When you do f of negative 1 right here, it does the absolute value of it first, so it's just like you did f of 1. And so it's going to give you the same answer of 2. So then basically that's why this thing is a reflection, is because you've fooled it into giving the same answers as it would have if it used a positive 1. Now I know that's confusing. It took me a couple of years to process this completely, but if that's not going to work for you, what matters is that you know how to go, okay, I know that these don't work anymore, and I know that I just have to reflect. Hello, sir. Hold on. Awesome. Can you do it from the hallway? It'd be better for all of us. I'll pause for a second, the video. Okay, so I got to ask a question here. What's the difference between absolute valuing the f of x and absolute valuing just the x? Here's the way I want you to think of that. F of x is my original function, the blue thing there. Let's get rid of all this extra junk here. Undo that change. Okay. So if I do the absolute value on the outside, you've heard me say f of x is like y, haven't you? F of x is like y, right? I'm absolute valuing the y's in that case. The y's are the height. And the y's that are positive are the only ones that will change because absolute valuing a positive number, positive ones won't change. So these are all the ones that have positive y's right now. They already have positive y's, so they aren't going to change. So then if I took this as the parent function, then my new answer would be like this, because I had to move the stuff that was negative y's and make them become positive y's, and that makes it effectively flip up. So my final answer for this kind would be like this, versus the other kind where you do f of just the x. That's going to change just your x's that are negative, because your x's that are positive don't care that they got absolute valued. And so that kind, again, if we started with something like Mr. Turtle here, and we absolute value the x's that were negative are over here. They need to go away now because they're absolute valued and they're positive now, so they can't, that's not going to be the same, so this part gets erased. And then on this kind, where we absolute value the y's, the x's, once you have erased that side, you just have to reflect this side over there. And again, I don't want to try to explain it again, what's to y, but you have to trust me that I've explained it enough times that I need to stop. and just say it's a reflection. Does that summarize it well enough? Yes?
So if it was a negative x,
Yes, so when you, for instance, put in x is -2, when you put in -2 into this function, do you get how the very first thing you would do is absolute value the -2? So it's exactly as if you had just said f of 2, which means you revert back to what's the answer for f of 2, which is that spot right there, which the answer is 0. Remember, it's not the x, it's the y of it. And this answer was 0 in the first place. So you'll get the same exact answer if you do f of absolute value of -2 or if you do f of 2. They both give you an answer of 0 either way. So that's why this one has to be 0. I don't know if that answered your question well enough, but all right, we've talked about that enough, I'd say. So now the last topic is piecewise, and I think it'd be best for me to just do one of those off the sheet with you. So everybody turn to problem number 4, and let me help you do problem number 4. Okay, pause for a second while I get set up. Okay, I did some color coding here so that you could see problem 4 with the 3 parts of it. Now, the way I would start is I would start with your border lines between your functions. And would you agree that -3 seems to be an important spot? It shows up twice, right? So x equals -3. I would make a dotted line right down your graph right at -3. That's dividing this function into parts. And there's the left part. There's the middle part, which is between -3 and 5, which means I should make another line at 5. And the end part, which is bigger than 5. So basically, I got a function in here. I'm going to have a function in here. And I'm going to have a function in there. Okay, so we draw those dotted lines first. Now, let's graph the one that is less than -3 here. Maybe I should switch to a blue pen to do the blue function. So this is what I'm supposed to graph in this zone right here. Now, how am I going to do that? I personally like XY charts. You know my affinity for XY charts, and I think it works. It keeps you from, like, by accident, like, doing it the wrong way. So now I'm going to put in -1/2 of something. Well, I better pick x's that are in my little zone here, right? So maybe I should pick -4, because that's clearly in the zone. Okay, so I put in -4 here, and I see what happens. 1/2 times -4, -1/2 times -4 is +2. 2 minus 1 would be 1. So -4, 1. There's a dot right there. Now I know intrinsically that this is an equation that has a slope of -1/2 and had a y-intercept of -1. But I can't do the y-intercept because that's in this zone over here where I'm only supposed to stay in this zone over here. Okay, so that's why I'm going to use the XY chart. Now I'm going to try -5. Stick it in -5. Oh, wait a minute. I'm going to have to take 1/2 of -5. I right away would cheat and change it to -6. Just because it's so much easier to take 1/2 of 6. So -1/2 times -6 would be +3. +3 minus 1 would be +2. So then -6 goes with 2. Look at that. And I know it's a straight line. So I'd probably just start going like this and say, okay, I know this thing's a straight line that runs right through there like that. Now, do you remember me telling you that the borders are where everybody makes their mistakes? Please be careful on the borders. Okay? Ask that Marine that went over into Mexico. Gotta be careful at the border. He's still there. So I don't want to go into it because it gets me all fired up, but we got one person illegally and they get thrown in jail for like forever, and they told the people crossing the border, I have firearms, I wasn't meaning to cross the border here, I took a wrong turn, and then they threw him in jail anyways, even though he declared what he had in his car. It's not like he was trying to smuggle weapons across the border, but anyway, he's still stuck there. This spot right here at the border. It's really important. So does this function own that border point? No. The red one owns -3. So I put an empty spot right there. That's critical, and a lot of people will get that wrong on the test. That's why I keep pounding on it. The borders are so important. Okay, now let's do this part right here. The absolute value of x plus 5. Well, in this area where I have like a normal xy axis in it, like this little zone in between here and here, I might as well just graph it like normal. So I'm going to graph a V shape that's moved up 5. There it is. It's a lot faster. Why am I not using an XY chart? Well, actually, I'm going to check it with the XY chart in a minute here. But and why am I not using red? I should be using red. You don't have to or anything, but I think it makes sense in the context of the problem. The V shape shifted up 5, so it's right here and here. And it appears to own both of its borders. Look, it says or equal to on both borders. So I'm putting a solid dot here and a solid dot there. Okay. And then the last part is this, the 3 square root of x minus 5. And it's an x is greater than 5. All right, so that means basically in this zone right here, I have to graph this part right here. So I'm going to make an XY chart for that again. And I'm going to stick in some numbers that work nice. Like for instance, I'd love to have this come out to be a positive 1. So I'm going to put in x is 6. See, I strategically chose that because now square root of 6 minus 5 is just the square root of 1. The square root of 1 is 1. And then I times it by 3, and I get 3. So 6 comma 3 is on my graph. Over 6, up 1, 2, 3. There we go. Now I'm going to pick something also in my zone here, like 7. 7 minus 5 would be the square root of 2. That's going to be a pain. 8, 9 maybe. I'll do 9. Because, you know, 9 minus 5 gives me 4, and that's going to work nice. So I'm putting in a 9 here. 9 minus 5 is 4. Square root of 4 is 2. 2 times 3 is 6. 9 comma 6. 9 comma 1, 2, 3, 5. 6 is right there. And if I know that this is a square root that has been stretched, then generally speaking, I know it's one of these kind of deals. But I don't know what 5 is. I better do 5 now. If I put in a 5 on my chart, I put in a 5 right here. Oh, that's going to work nice too. 5 minus 5 is 0. Square root of 0 is 0. 3 times 0 is 0. 0. And after all that work, I'm still going to get it wrong. What did I do wrong? The border. I got two things that they think that they own the border. Both these functions. This function says he owns it, and this function says he owns it. Can't be both of them. So, which one owns it? The absolute value owns it. So this guy shouldn't have had a solid dot right there. There should be an empty dot right there. So I'm going to fix that by erasing it and putting an empty dot right there. Because this says greater than 5 is where that function kicks in, not at 5. All right. Obviously, kind of got obsessed with that border analogy just because it's the place where you're most likely to screw up. Okay? So try to keep that from happening on your tests. All right. I think that covers everything we really need to know for your test. And your test is tomorrow. Again, I'll be gone. I have a funeral to attend. So I'll have the tests all set out for you. The sub will just hand out the tests. And after the test, I'm not going to assign any homework. You can just enjoy a complete night off. And then the next day, we will launch into new material. Okay, any last questions before I stop the video? Okay, that's all I got for you for today. You can always ask me more questions later.